All right, let's have a look at the next idea, adding and subtracting of the ordinates, sometimes also called superpositioning. I think I use that term in physics. So when you add two graphs together. So the way we tend to do it is draw both graphs individually and then physically add the y coordinates together. So if I've got something like x plus 1 on x, well, there's y equals x, there's y equals 1 on x, and then I pick key points to add together. I mean, logical ones are points of intersection, because then you'll know it'll be twice that y value, because we'll add them together. Is that the first one I did? Yes, it is. There you go. And the one down the bottom as well. But then you just basically pick as many points as you need until you start getting a feel for what the curve's doing. After you sort of do a few on this one, it sort of becomes obvious what's happening, and it sort of makes sense. Because if you look at y equals 1 on x, it's getting closer and closer to the x-axis. So in other words, you're adding on numbers that are getting closer and closer to 0. So it's logical that this new curve is going to get closer and closer to x. Thus, y equals x being an asymptote, which is, of course, what we knew anyway, because if we look at it, it's in that format that we're used to seeing, and y equals x would indeed be the asymptote on that one. So there we go. So I say, as many terms as points as you need to work out the shape of the graph. Another logical point, we haven't got any there, would be like x-intercepts, because obviously you're adding 0 to the other curve, so it'll stay on the other curve. Stationary points, we didn't have any on this one, of course. There's no stationary points on y equals x and 1 on x. They'd be good ones to look at as well and work out where the new point goes to. So a couple of things to keep in mind. If you've got a discontinuity, which we did on that last one, y equals 1 on x had a discontinuity. Well, the new function is still going to have that exclusion in the domain. Because I can't all of a sudden add something which doesn't exist and get something that exists. Now that can create an interesting curve, because imagine you've got something like this. I mean, why you'd want to add these together, I don't know. But I mean, just imagine you did. You've got x plus 1 on x as one curve, and then 1 minus 1 on x in the other curve. Now clearly x can't equal 0. Okay? But if I add those together, I simply get the line y equals x plus 1. So you would think that you're going to get the straight line y equals x plus 1. But that discontinuity still exists because you're not actually drawing the line y equals x plus 1. What you're drawing is y equals x plus 1 on x plus 1 minus 1 on x. That is the actual thing you're drawing. And that's got a discontinuity. So in this case, there'd just be a point discontinuity there at x equals 0. So the point 0, 1. So you can get some strange ones like that sometimes when you're adding curves. X-intercepts. If when you're drawing the two curves you notice symmetry about the x-axis, so if function x is equal to the minus of the other one, so you've got the same amount above as below, then obviously they're going to add together to give 0. It will become an x-intercept on the new curve. So that's another good one to look out for. Symmetry. I was trying to work out how to actually write this. And I thought, okay, I'll say it this way. Like functions retain symmetry when added. So what I mean by that is, if you add an odd function with an odd function, so they're like symmetrical functions, it will still be an odd function when you add them together. Same with even. But if you add an odd with an even, you're not going to get anything there. You're going to lose some symmetry. Here's a absolute value one, which we've seen this sort of type before. The way I like to approach these is look at the critical points or break it up in between. And so the key point is what makes the absolute values equal to 0 in something like this. So first of all, I'm going to say, well, what happens when x is less than negative 3? Because negative 3 is when the first one becomes 0. Now if I was to pick any number that was less than negative 3, then x plus 3 would be positive or negative. So we'd end up with a negative number. But we're saying absolute value. So what that means is this graph, when it's less than negative 3, it's actually going to end up being the negative of x plus 3 will be the answer. And then I do the same with the other one. Well, 1 minus x. If I was to sub in a number less than negative 3, see how we go with this one, into 1 minus x, positive or negative? Right, so that one will stay the same. So that'll just be plus 1 minus x. And then I can work out what I'm actually graphing for x is less than equal to negative 3. It'll be the line y equals minus 2x minus 2. Then we'd keep going. The next interesting point is x equals 1. So, all right, what happens in between minus 3 and 1 then? Same deal. Let's pick any number that's in between minus 3 and 1, sub it into x plus 3, positive or negative? Good. So that one will stay as x plus 3. Sub it into the second one, also positive. And I can add those together, and we just end up with a constant y equals 4 for that section. And then let's have a look at what happens if I pick a number that's bigger than 1, x plus 3, positive, 1 minus x. That one's negative, so this would be minus 1 minus x. So for that section, I'd be drawing y equals 2x plus 2. And so now I know what that graph will look like. So there's the first bit going up to x is minus 3. Then in between minus 3 and 1, we've just got the straight line. And then after 1, we get the line y equals 2x plus 2. So we get that interesting shape. Okay. Now, if you were subtracting graphs rather than adding graphs, I tend to think of it as, no, I'm still going to do it as adding, but I'm going to add the negative graph, so the reflection. So if I was going to do y equals x minus sine x, I'm not looking at it and thinking, okay, I'm going to get x and subtract sine x. I'm looking at it as I've got the graph y equals x and the graph y equals minus sine x, and I'm going to add those two together. And so then I'm just keeping the same ideas then, because I'm always adding graphs. So there's y equals x. There's y equals minus sine x. So again, we want to pick some interesting points. Well, clearly the origin's going to be an interesting one. It's 0 for both of them. Add them together. It's going to stay as an x-intercept. What else have we got? We've got a couple of other x-intercepts. So it'll be on the red line for those ones. Then we've got those stationary points. So I would get those. I'm going to add to the red curve, plot those in. Unfortunately, my graph isn't big enough, but obviously that would keep going. We'd end up with, it's not actually a sine curve, but it's that up and down. It would be winding along the line y equals x. Okay. So questions 1 to 7 and 8b are on adding and subtracting.